In this episode, we are expanding our interaction system to include opening and shutting doors. Instead of simply pressing an interact button like E, we will be using our mouse to push and pull the doors open. We will also be able to define how far the door can open by setting its maximum rotation in the inspector panel. And welcome back. Today we are going to be adding the ability to open and close doors to the interaction system by moving our mouse forward or back. If you haven't seen the previous episode, we are going to be reusing the same interaction controller and interaction component system that we've been building up. So if you haven't seen that video, you should check it out. But the logic for opening and closing the doors can be adapted if you have a different kind of system set up. So if we're going to open and close doors, we need to build a door first. So let's start there. So back in our project, we are going to go ahead and create a new scene for our door. So create a new scene. This is a 3D scene, and we're just going to call this door. And to add our door, we're just going to hit Control A, and we want a static body 3D. This is also just going to be named door as well. And for a static body 3D, you need two things. You need a collision shape, and then you also need a mesh instance 3D. Now, I think what we're actually going to do is delete the collision shape 3D and just build the mesh out first. So let's go ahead and do that. Let's go over here to the right and create a new box mesh, expand the mesh, and let's change the size. Let's make it 1.6 meters by 2.6 meters by 0.1 meters. That looks pretty good. And to drag it up, we're just going to pull it up here and see roughly where it ought to be. Right about there, maybe. Let's check the transform. That's probably going to end up being about 1.3 meters. And then we want this to move so that way we have a bottom that matches right where the X, Y, and Z axis are. And that looks like it's going to be about 0.8. And now we have a door. And the reason I wanted to get rid of the collision shape 3D is because we should just be able to right click and hit create collision shape. And a sibling tri-mesh should work fine for what we need. Let's go ahead and scroll back out. And the only other thing I want to do is put a texture on this. So let's go to our prototype textures. And I think purple is a good color. Let's go ahead and drag this on there. And that looks good. Actually, we are going to hit Control Z on that, and we're actually just going to add the texture to the surface material override, and that's just going to give us access to the UV1 so we can make it triplanar. That way, it kind of lines up a little better with the rest of the textures in the game. So I'm now noticing on this collision shape, you can see there's a lot of kind of artifacting going on here, and I don't want us to have a problem with our collision. So we're actually just going to go ahead and get rid of this collision shape 3D, and we're going to make it ourselves because it's actually going to be fairly simple. So create a collision shape 3D. It's going to be a box shape, and the good news is we already know the size for it. It's going to be 1.6 by 2.6 by 0.1, and now we just need to affect the transform in the exact same way, which was 0.8 and 1.3. So that seems to be a lot simpler of a collision shape. Now, if you're wondering why I have the door not centered, but rather have a point right here where all three of the axes meet, the reason for that is we are going to be rotating this door to open it, but to affect the rotation of the door would just turn it like this, which we don't want. Most doors are going to turn open completely and fully based on the hinges on whatever side of the door they're on. And for that, we're actually going to need to add a pivot point. So click on your top level node 3D door and add another node 3D right here. Drag it up and then drag the door static body onto that. Rename that node 3D and call it pivot point. So now instead of rotating the door, we're actually going to rotate this pivot point here. So that way the door opens as it would against a wall. And that's going to make it a lot cleaner to move this around when we are writing our code. And now the whole point of us writing this interaction component is so that way we can just drag and drop this component onto every single object we want to interact with. So go ahead and find where you saved your interaction component scene and drag it, and we're going to put it on our door. I'm going to go ahead and save this under Objects and call it Door. Now let's go ahead and jump into the code and get this thing working. So here we are back in our interaction component script. We are going to need some variables to get this door moving around. So I'm going to put my new variables near where the player hand is. So we're going to create a variable, And this is just going to be a reference to the pivot point of the door. Now, if you remember, we also built this interaction type enumeration that is going to let us set up what kind of object we're working with. So we don't want to be able to pick up and throw doors. Rather, we want to have the doors have their own logic. So go ahead and add the option for door to our enum. All right, so now we're going to come down and add to our ready function. We're going to do another match interaction type. And this time will be our first instance of using the door interaction type. Now, if this is a door, we need to get some information about the door. What we need right now, I guess I should say, is the pivot point of the door. And we're going to do that the same way we were originally getting the player hand. So get tree, get current scene, make sure that S is not capitalized. We also want to find the child, and the child we want to find is the pivot point. Recursive search not owned. Now, one important thing we need to do for the sake of the door is access this as a unique name. We are going to also add one more Boolean value. We're going to add a variable that's called lock camera. This will be set to false. And what lock camera will do is if you are interacting with this object, the mouse movement will no longer move your camera around. And that's pretty critical when you're interacting with switches and doors that are also using mouse movement. Otherwise, you could get very janky reactions and it's not an enjoyable experience. So make sure you have a lock camera variable. And let's go ahead and come down into the pre-interact up here. And let's add an interaction type here, interaction type for the door. And we're just going to say that lock camera is true. Now we also need to make sure that we unlock our camera when we are done interacting with doors. So down here in our post interact, we want to say lock camera equals to false, because when we're done opening the door, we want to be able to look around again. All right, so let's go ahead and write some code for this. Now the door is going to be based off of the mouse movement, which means it has to be done within the input method. So that's where we're going to go ahead and put it. So we need to check if is interacting, and we want to check if we're interacting because this is going to be running every frame, so we don't want to be making calculations for objects we're not actually interacting with. So if we are interacting, we also want to make sure what type of action we are interacting with. So we're going to match interaction type. If this interaction type is a door, this is where we're going to do our logic. So for this door, we want to see if we're actually clicking on it. And if we are, let's perform some kind of logic. So we need to ensure that what we're doing is moving the mouse. So if event is input event mouse motion, then we're going to do something. And what we're going to do is we are going to start at the pivot point, and we are going to rotate on the y-axis. And that is going to be done to the event relative, which once again is the movement of the mouse in the y-axis. And that's going to be times a sensitivity on how fast the door is actually going to open, in which case it'll be 0.001. And make sure you have a colon there. So let's go ahead and set this up with our interaction controller and see what we can do. So the only thing we need to add on our interaction controller is a function down here at the bottom. It's going to be called func is camera locked. And this is going to return a Boolean value. And it's going to check if we have an interaction component, meaning we know what object we're interacting with. We are then going to check if the interaction component dot lock camera and interaction component dot is interacting. And if we are doing both of those things, we want to return true. And if we are doing none of those, or any combination, we want this to be false. So this is going to be called in our player script because that's where we're actually moving our camera. So let's go to our player script next. So here is the player script, and right here in this function method is where we did our calculations on how the camera is going to move in our game. If the camera is locked, we don't want to be moving this. So all we need to do to make that work is say, if not interaction controller dot is camera locked. So we'll get that value from the method we just wrote and check. If it is locked, we don't want to perform this logic. Now, we don't actually have an interaction controller referenced in our script. So let's go ahead and do that now. Go back to our player and come up here to the top, grab our interaction controller and hold Control and put it into your script. So now there should be no errors, and we can probably test this to see if it'll work. So here in our sandbox, let's go ahead and grab an object and just put a door down over here. Hit save and start it up, and let's see what happens here. Oh, we have a problem. We did not set up our door. Now, this is where the beauty of the interaction component comes in. So let's go ahead and go to our door scene, go to where our interaction component is, and you'll see here we did not set this up. We need a reference to our object, door. Now, we're not actually going to use that, but it's always good to set up. What we need to define is our interaction type. So this is no longer a default object. This is a door object. So go ahead and save that, and let's run it again and see if we can get this door to open. And as you can see, the door will open as I move the mouse, but it's also kind of going all over the place. So it is spinning on the pivot point as I move my mouse forward and as I move my mouse backwards. So we're going to have to clamp this, and we're going to have to get some more values about the door. So back here in our interaction component script, let's go ahead and add another set of variables. This one is going to be a variable called starting rotation, which is going to be a float. And this is going to store the rotation of the door when it first is placed down or when the game first starts. Now we're also going to need to keep track of the maximum rotation we want the door to open. Now I'm going to write this as an export variable because when you're building a game and you are placing door assets, there may be doors that you only want to open a little bit, doors you want to open, let's say 90 degrees, and doors you want to be able to open wide, like French doors, maybe at 160 degrees. So when you set up your door, you are going to need to define a value. For me, 90 degrees seems fine. So let's go ahead and save that, and let's set this up in our ready function. So in our ready function, we want to say our starting rotation is equal to our pivot point, its rotation on the x-axis. So that'll keep track of where the door was when we first started the game. And now we need the maximum rotation. And this needs to be defined relative to the starting rotation, because if you place a door down and you're kind of building your scene and you want to start the door maybe cracked and then open it another 90 degrees, we want to make sure that this calculation is still accurate. So we need to say that the maximum rotation is degree to radians, because this is a radian value. However, that's actually kind of difficult to think about in radian values. So rather that, I would rather talk about it in degrees. So this is going to be a little clunky, but radian to degrees of an object, of a calculation, I should say. And we're going to do the starting rotation, and then outside of that is going to be plus 90. So what we're saying is we want to take our starting rotation, which is going to be a value in radians because this is given to us by Godot, and we want to make that into a degrees value, and then we want to add 90 to it. And actually what this should be is we should say our maximum rotation is plus our maximum rotation. So don't hard code your maximum rotation, you should put it like that. So if our starting rotation is at 0, let's go into our 3D scene to talk about this. If our starting rotation here is 0, we want to add 90 to 0, so 90 total degrees, and put that into a radian value. So that way the door should only open to 90 degrees, and it should always stay between these two values here. So let's go ahead and add that calculation to the door logic as well. So down here in our input method, let's go ahead and close out some of these functions here. Down here in our input method, after we calculate our pivot's rotation, we are going to want to clamp it, similar to the way we handled our camera in the up and down camera mode. So that way we couldn't look down below our feet. So we're going to say our pivot point's rotation in the y-axis is going to be clamped. And it's going to be clamped between, we're going to clamp this value, and it's going to be clamped between our starting rotation and our maximum rotation. So now we should not be able to open the door more than what it is right now. So let's go ahead and try that and see what happens. So as you can see here, if I move my mouse, let's reset it. If I move my mouse forward, the door opens, and if I move the mouse back, the door will close. Now, the door right here is backwards, so as you can tell, it doesn't really make sense for me to walk up to this door, press forwards, and have the door pulled towards me. That doesn't really make much sense. So we are going to have to add in the ability to calculate where the front and back of the door is, so that way the mouse movement is always happening relative to where the player is in the game. Down here below our default throw method, we are going to add another function that we are just going to call set direction. And set direction is going to take in a vector 3 that I'm going to call a normal. Now, if you don't know what a normal is, that's just a way of representing the way a certain object or a certain face is looking. It handles direction. And this will make more sense as we write this out. So what we really just want to check is if that normal value's z is greater than 0. And if it is, we are going to say that the front of the door is what we're looking at. Otherwise, the back of the door is what we're looking at. So we'll set isFront is to false. So let's go ahead and add this as a variable. Up here, we'll just say var isFront of type bool. All right, so now we should be able to tell the door which way it is facing. So let's go ahead and add this into our interaction controller. So back here in our interaction controller, when we are first pressing the primary, so wherever you are calling your pre-interact, when you are first interacting with the door, we just need to add a check. So we need to check if the interaction type of the object that we are interacting with, because we don't need to know which way cubes are facing to pick them up and throw them. We need to check if that type is interaction type dot door. So a pretty long, robust if statement to just check if this is a door, but that's all we're doing. And if that's the case, we're going to call the method we just wrote called set direction. Now remember, set direction is going to take in a vector 3, but we need to do a little bit of calculation first. So what we need to know is our player here has this interaction raycast, and that's going to be hitting the front of the door at some point, or the back of the door at some point. And so we need to know what we're actually looking at and where on the door we're touching it. So for instance, if I'm facing here, I'd maybe hit the door right about there. So I need to know that I'm on this side of the door. Whereas if I spun around and maybe I was hitting it here on the brighter side, I'd need to know I was on this side of the door. So how we're going to do that is we're going to call our interaction raycast and call get collision point, just like that. However, this only returns the point in 3D space. What we actually need to know is where on the door we are colliding. So this is going to enter its own set of parentheses, and we need this relative to the door, which is our current object, and we're just going to call to local. So let's go over that again. What we're doing is we're finding out where on the raycast we are hitting something in the entire world, in the entire game, and then we are calling the door and saying, well, we're colliding with you. Where on your collision shape is this collision happening? And that's going to be a vector 3 in world space. So then we're going to call our set direction, which we'll know is if the z is, let's look at it this way. If the z is negative, we're hitting this side. If the z is positive, we're hitting this side. Hopefully that makes sense. So back here in our input function, we just need to affect our rotation. So we're going to check if this is the front, we are going to rotate this way. However, if it's the back, we're going to rotate a different way. And the only way we're going to tell is just to remove that negative. So this relative y, event relative y, is just the way the mouse is moving forward and back, right? So if it's negative, I think that should mean the mouse is moving down. And if it's positive, that means the mouse is moving forward. So if we're looking at the front of the door, we're going to want to pull it towards us. If we're looking at the back of the door, we're going to want to push it open. So let's go ahead and go back into our sandbox and run it and see what happens. So here's the door. I click on it and I pull it towards me and I push the mouse back. So now if I go on this side of the door and I push it, you can see it opens like that, and I can pull it back towards me. Push forward with the mouse, back towards me. Let's go ahead and modify our door with some labels just so this makes the most sense. Also, this door is indeed backwards, so I'd want to turn it like that. So here in our door, on the static 3D mesh, or on the static body 3D, we're going to add a label 3D, and this is going to get a text component that's just going to say front. And I'm just going to pull it here and drag it up like that. All right, so now I'm going to go ahead and duplicate this label. Make sure that's on the door. And as you can see, it's all haywire. So let's go ahead and reset that transform. We're going to want to spin that around completely, 180 degrees, move it slightly forward, and put that somewhere at the top. And this is no longer the front, but this is the back. So there's our front and there's our back. So let's go back in our sandbox and demonstrate this one more time. So here I am looking at the door. This is the front of the door. So if I click on the door to interact with it, and I push my mouse forward, you can see it opens to our maximum rotation of 90 degrees. And if I pull the mouse back towards my body, the door is here. And by the way, this is interacting and I can still move around while I'm interacting with the door, but you can tell that my camera is not moving. So forward for front, backward to pull it in. So now on the back, this should be the opposite. When I grab the back and I pull towards my body, the door opens. However, if I push the mouse away from me, it's closed. Pull to open, push to open. So now doors should work in your environment, and it should be extra easy to set up any different door assets you have, because all you'll have to do is drag the interaction component scene into your game, make sure the interaction type is set to door, and then set its maximum rotation, which, by the way, depending on where you are in the world, you just need to know how much it's going to open, right? So let's say I didn't really know how much I wanted this to open. I grab the pivot point and just rotate it. So let's go ahead and change this to something like 136 degrees, something super random like that. You know, maybe your environment, there's like a table there that's going to hit it. So let's go ahead and save that and run the game. And we're just going to push the door 136 degrees, just like that. And of course, this will work in the opposite direction too. Oops. Pull out. There you go. So now this door works fine, and any additional doors you need to add from asset packs or maybe some that you create should work right out of the box. So there's actually going to be a fairly major bug in our code that I want to obviously fix, but I want to show you to kind of demonstrate that when you're building out these systems that are kind of complicated, you're going to make mistakes. And I feel like a lot of tutorials on YouTube, they are just perfect right off the bat. And for developers just starting out, that can be very discouraging when it seems like everyone else is doing it perfectly and you can't figure it out. So let's go ahead and talk about some door problems that our system has right now. So if I go to our sandbox, and I'm going to go ahead and drag in a few of our door scenes here and just have them face towards the player. Like that. Let's actually just put you there. All right, so let's go ahead and run this and you'll see what I mean. So if I walk up to our first door here, you'll see I can grab it and I can pull it, and all of the logic we just wrote is still going to work fine. However, if I go to our second door here, you're probably going to see a problem. Yeah, you can see we are still pushing and pulling our original door, and it's going to be the same for our third door. So this has to do with one of the lines of code we wrote, which was kind of dangerous, but in terms of prototyping, it was fine. But let's go ahead and go back and refactor it and talk about why we really shouldn't be doing it. So here in our interaction component script, you'll see we have this get tree, get current scene, find child. Now, these are generally not great calls to make because even if they work, they are very intense, especially when you have a lot of nodes in your scene tree. But the reason this bug is happening is because this pivot point is going to find this tree on the left, and then it's going to try to find a child called pivot point. Now, this is kind of a spoiler here, but if you look at these two doors, if I make these local, they both have a pivot point here, which means what's happening is on ready, pivot point here is being assigned to the first door's pivot point, and every single door we try to add to our game will have the same exact problem. So you'll never be able to move more than one door. So we're actually just going to go ahead and get rid of this line of code here. And the way we're going to fix this is just expect the developer to assign a pivot point when they are creating the door scene. So let's go ahead and add that. We'll take our pivot point variable here, hit Control X, and drag it up to our export variables and make sure it is indeed an export variable. Now let's go to our door scene, 3D, and click on our interaction component. And over here where you see the pivot point, just go ahead and click Assign, and assign the node 3D that represents our pivot point, and hit Save. And this will work because the onReady function will run once all of the nodes are loaded. And so once the interaction component runs its ready method, the pivot point will already exist and it will be assigned to the pivot point. Now I do want to demonstrate what happens if you try to use a door that doesn't have a pivot point assigned. For this, I deleted them, so I'm going to need to drag the door back into our sandbox here. So now we have a door that has a script on it that's expecting a pivot point, but it's not going to get one. So you can see here it's going to bomb out and it's going to say rotation on a base object of null. So there was no pivot point assigned, which means it's going to bomb out. Now, you could add in some kind of check. If it's null, don't perform any rotation. I'm actually more happy with it bombing out because this is a whole setup. And presumably your game would only have, let's say, 5 or 6 door assets. And you should really be setting them up correctly the first time around. So this does put a bit more of an onus on you to bring your assets in and set them up correctly. This also makes our doors work and be more reliable at the same time. So let's go ahead and reassign that pivot point here. Go ahead and save. And we're just going to Control-C, Control-V some doors and bring them around the level here. Oh, let's not do that. Let's go ahead and, we can Control-C, Control-V, but we should drag the doors out from under each other. So let's go ahead and set this up as. All right, so let's run the game. So if I walk up to the front door, I can pull this one, I can pull this one, and finally I'll go around back and I can pull this one. So now all 3 of our doors are going to work independently of each other, and that should solve that bug. I am recording this after I have done the prototype for the switch and the wheel, and we still have one more get tree current scene find camera call, or find child, and it's on the camera. This one is a little bit safer because realistically you're only going to ever have one camera 3D. However, I'm thinking about new additions to the tutorial series, and there may come a situation where we have another camera 3D. Now, we could do the simple thing and name this one player camera 3D and then have the second camera named something else. But at the same time, I will be thinking of a better solution when we get to the wheel episode. So stay tuned for that. And in the next one, we are going to be talking everything about switches. So get ready for that one as well.